Hello, welcome back to our Chapter 6.1 video lecture series. In the last video, we ended looking at the margin of error formula. And then we went through and converted to solve for n. We take this formula and solve for n. And that gives us a sample size. If we're trying to figure out how big a sample size we need to be within a specific margin of error, we're going to use this formula. So if we have a previous sample, let's go here, or if we know from a census, a population proportion, we could plug in this value p. But if we don't know anything about the proportion or don't have a previous sample to call upon, we're going to use a 0.5, so p to be 50%. And to do that, I want to visualize why we use a 0.5. I'm going to say this is give us the most conservative estimate. But let's go through. I want to figure out the sample size needed to calculate a 95% confidence interval with a margin of error of 2.5%. All right, so I copied this question over. I want to go through this in detail. So I want to look at if we don't know P or P naught, we're going to use that 0.5 to see why. Let's figure out the large sample size needed to calculate 95% confidence interval. All right, so first thing to note that Z star, if we're doing a 95% confidence interval, is 1.96. And the margin of error we're given to be 2.5%. So to convert that to decimal, 0.025. So we've got our given information. So if we just plug that in the formula, we would get n equals 1.96 over 0.025 squared, p hat times 1 minus p hat. And I'm going to write this, I'm going to throw that in my calculator, just the 1.96 over 0.025, and then square it. And this ends up being 6146.56 p hat times 1 minus p hat. All right, so I want to look at this as a graph. Okay, we're going to figure out the sample size. I've got this value right here. So what I'm going to do is I'm going to go over to a graphing calculator. I'm going to tweak this a little bit. And here what I've done is graphed. I just need to change this number up here to 6146.56. So I've graphed the number, the sample size needed. This is your Z star over the margin of error squared times P times 1 minus P hat. And we get, if you remember, this ends up being an upside down parabola. And the reason why we use 0.5, if we look at here, sample size needed, this graph, the green graph tells us the sample size we need. If we know a P value, we plug it in, but if we don't know a P or P hat value, if we plug in that 0.5, it makes the sample size as large as possible on this graph. So this is the reason why we're going to use P equals 0.5 if we have no other information, because that's going to give us the most conservative. We're going to tell us, okay, we need to get at least this size of a sample. So if we go back to the formula and plug that in, we get the 6146.56 and times 0.5 times 1 minus 0.5. And if I throw that in my calculator, that ends up being 1536.64. And I go here, really, I could change this formula to not equals. This needs to be greater than or equal to. All right, we're looking at sample size. We can't have a fraction or decimal of a fraction of the sample size. So always round up to the nearest whole number. So in this case, we need a sample size of at least n equals 1437. So 1537, excuse me, 1537. So always round up. no matter what the decimal is. If the decimal said 0.04, I'd still go to 1537 right here. All right, 1537 is our minimum sample size. All right, suppose we might estimate the proportion of college students that sleep at least 8 hours a day with a margin of error of 0.03 with a 99% confidence. All right, let's run through this. All right, we copy that problem right here. And I'm going to copy and paste. We're using the same exact formula. We want to figure out sample size. So if we have 99% confidence, what is Z star going to equal? It'd be 2.576. And if you forget that, don't forget you can always go to the normal distribution, click on two-tail, and make sure that middle area says 0.99. And that's where we get the Z star of 2.576 for 99%. And we're given that margin of error is 0.03. So we go to this formula. I'm going to take that Z star, 2.576, over the margin of error, 0.03, square it. And since we don't know anything about the proportion of college students that sleep at least 8 hours a day, we're going to assume that P is 0.5 and multiply it times 1.5 times 1 minus 0.5. And if I throw that in my calculator, 2.576 over 0.03 squared times 0.5 times 1 minus 0.5, I'd get 1843.27. Go through that process. But we need a sample size. It needs to be at least this big. So sample size needs to be this number or bigger. So we need a sample size of at least n equals 1844 as my sample size. 1844 to make sure I'm within a 3% margin of error and 99% confidence. All right, we take a random sample of 500 moviegoers in January 2013. 320 of them said they are more likely to wait and watch a new movie in the comfort of their new home. If we want to compute a 90% confidence interval for the proportion of moviegoers who are more likely to watch a new movie from home, and then I want to know what is the margin of error. Okay, so let's go through this example. I copy the information down here. Random sample of 500 moviegoers. 320 of them said they are more likely to wait and watch a movie at home. Compute a 90% confidence interval. So first thing I want to note we have at least 10 successes. 320. And 10 failures. I would take the sample size of 500 minus 320, and that's what, 180? So we can use Z. And if we're looking at a 90%, that's 1.64. You can always go to stat key to get that value again. So we can use that Z star 1.64. And the confidence interval formula is P hat plus or minus Z star, that's weird, times the standard error. And that standard error formula for confidence intervals is to take P hat times 1 minus P hat, all divided by N. So this formula we use for a single proportion. And for this value, P hat, I'm going to write it up here, P hat is the 320 over 500. And let's see, I'm going to throw that in my calculator to get 0.64. Oops. All right, P hat is 0.064. So now I have everything I need to plug into this formula. 0.64 plus or minus. Z star is 1.64. And then times the square root of 0.64 times 1 minus 0.64. And then that whole thing will be over the sample size, in this case, is 500. So this becomes 0.64 plus or minus. If I take if I were to throw the standard error formula, the square root of 0.64 times 1 minus 0.64 over 500, I would end up with 1.64. And the standard error would be 0.021. 0.64 plus or minus, and if I multiply that times 1.64, 0.035. So let's get some more space here. So the 90% confidence interval is, I'm going to take 0.64, subtract that number, 0.035, 0.605, to 0.64 plus 0.035 to get 0.675. So we are 90% confident that between 60.5% and 67.5% of all movie goers are more likely to wait and watch a new movie at home. So the confidence interval, and I want to notice that margin of error is this 0.035. Here we have our margin of error. Okay, so I went through and calculated the confidence interval and kind of highlighted this margin of error. And the reason I wanted to highlight the margin of error, if we go back here, suppose we take the sample, and suppose we want to create a 90% confidence interval, but we want to be within a 2% margin of error. And we assume the January 2013 sample proportion is still accurate. So if we wanted to figure this out, I'm going to go back up here. We're going to use this is the sample size formula. All right, and if I want to fill this value out, fill out all this information. If I want 90%, I'm still looking at 1.64 to my z-star. Margin of error, we're looking for 2% margin of error. So I'm going to throw 0.02 in the denominator. And now here in this case, if we're assuming the sample is still accurate, instead of 0.5, I'm going to throw 0.64 times 1 minus 0.64. And if I throw that in my calculator, 0.64 over 0.02 squared times 0.64 times 1 minus 0.64, I get this to be 1549.2